Hello, Algebra 1 students. If you're not in my class, I am Mrs. Taufa. I am one of the Algebra 1 teachers, and we're going to be creating some notes today. So what you need is you need a blank piece of paper, and you're going to have to fold this paper. So you're going to fold it in half, okay? And then you're going to fold it in half again, okay? But we'll get to that, but make sure you have a blank piece of paper. Pencils, pens, if you have crayons, colored pencils, something with color, that will help. I'm going to be using green and red or green and pink, so if you want to follow along that way, that's what we'll be doing. Okay, in Algebra 1, Algebra 1 is a foundation class, which means that everything you learn in Algebra 1 is going to carry through with you. And so you need to get a really good foundation. And one of the things that we hear from our geometry teachers and our Algebra 2 teachers is when you do exponents or you write the equation of a line, students will be like, I've never been taught that. And we know in Algebra 1, yes, you have gone over those things. And so what we've decided in Algebra 1 is that you're going to be creating some notes. And these are going to be called your math folder notes. And this particular set is going to be called the Evaluation of Expressions and Functions. So why a math folder? These notes are not your everyday notes, okay? These are going to be the highlights of the most important pieces of Algebra 1. They're really going to be a summary of each essential or each chapter that we cover. So there will only be about 10 of these that you will create. We're only looking at the most essential. And so the plan is that you are going to create a folder. So you all have a 3-ring binder where you're keeping your daily work. My class, I know I've asked you guys to get one of these type of folders. Okay, and you're going to keep these most 10 essential notes or summaries in that folder. And then when you leave Algebra 1 and head to geometry, you're going to take this folder with you. It is our hope that we'll be able to put this into Canvas as well, so you'll also have a digital copy. And the most important question, yes, these notes will be for a grade. Okay. First things first, you're going to take your piece of paper again, just like I showed you at the beginning. Take your piece of paper and you're going to fold it in half, okay? And then you're going to fold it in half again. So remember, when we take notes like this, the purpose is you're not going to look at these notes. You might look at them tomorrow. But the point is, in a year from now, when you're sitting in geometry class and your teacher asks, well, what is function notation? And you haven't seen it for a while, you're not going to say, I've never seen that before, because you will have your notes. These type of notes, you have to create them to last a long time. And you have to create them so that when you look back on them in a year, you understand what you wrote. It's not just putting some numbers down on a piece of paper. You have to be very purposeful, because in a year, you got to remember what you were trying to tell yourself. Okay, so you're going to have your paper, and you should have 4 boxes. Take a pen or your colored pencil and create your 4 boxes. Why 4 boxes, you might ask? Well, okay, you need the 4 boxes because on the short cycle or your next really big assessment, there will be 4 types of questions. That's why we want you to make 4 boxes. So your paper should look something like that on the screen, or what I showed you over here. Okay. You're going to title your notes. You got to have a title, Evaluation of Expressions and Functions. Okay, and that's what the title should look like. Just put it right there on the top. I'm going to give you a sneak peek. Oh, but mine will be, there you go, Evaluations of Expressions and Functions. All right, box 1. That's going to be that top left box. You need to write down that problem, and then you need to work the problem, but we're going to work it together. So go ahead and write that down, and I'm going to get my screen ready here. Okay. Chapter 1, we need a summary of what you've been doing, or the most important things of chapter 1. And what you have to be able to do is to understand function notation. But you already know function notation in a different way. And so we're going to start with what you guys already know. you know how to evaluate an expression. So you're given -3 times 5 minus this absolute value of x plus 9. Now what it's asking you to do is, if x is -8, okay, what is the value of this expression? So in my class, we've been doing all of our inputs. Okay, if it's an input, we've been writing it in green. Okay, so that's what that looks like. All right, so now let's write this out. I'm going to have a -3. Now let's actually substitute this in, times 5. Now my writing, guys, is not going to be as nice with these pens, minus the absolute value of something plus 9. Now that x, I'm putting a value in for x. You guys know how to do this. Okay, I am plugging in a -8. And once you've substituted in that value for x, we always put it in green in our class, just to remind you that's the input, then it's just PEMDAS. Okay, that's all it is. That's why we've been practicing so much PEMDAS, okay? Because at this point, you've done the hard part. Now you just go back to what you know. All right, so absolute value acts kind of like parentheses. That's the grouping symbol. You've heard of PEMDAS, but we've also talked a little bit about GEMDAS. The G stands for grouping now, because sometimes we have more than just parentheses. Absolute value is a grouping symbol, or like parentheses. You have to do that first. So -8 plus 9. All right, it's still living in that absolute value, and it's going to be a +1. All right, now I'm going to come over here and I'm going to look at my -3 times my 5. Okay, that gives me -15. And please don't drop this negative sign. It's got to stay out there. It's out in front. I don't get to just drop it. And so now let's take a look at what's going to happen. Well, what's the absolute value of 1? The absolute value of 1 is just 1. So I have a -15 minus 1. All right, calculator's out, or if you can do this one in your head, what is a -15 minus 1? Well, hopefully you're seeing that that is a -16. Okay, and we have been coloring that in red in my class, or pink, just to show that that is an output. So green is the input, red is the output. Again, this kind of question is not new to you. And so that's what box 1 is going to look like, okay? If you need to stop the video here, stop the video, finish these notes, and I'll show you what my handwritten notes look like. Okay, so this is what your box 1 should look like. These are my handwritten notes, so if it's hard to read when I write on the screen, here's what it looks like when I wrote it by hand. Again, if you need to stop and copy this, go ahead, okay, stop and copy it. And let's move on to box 2. So in Algebra 1, we always try to move you from what you know to a little bit harder notation. And so we started chapter 1 with these things called function machines. So at this time, in the top right box, label it number 2 and title that one function machines. So function machines are where we started looking at, here's an input, and then what's that output? Notice we said goodbye to y, and we now look at f of x. F of x is just a fancy way of saying y equals x cubed minus 25. There's nothing new about f of x other than the way it looks. All right, so let's try this one. Again, I'm looking at my input. So here is my input. It goes into this machine. And so we need to write out what that machine now does. So I have f of 5. Okay, my parentheses are really hard to write. I apologize, guys. So that's f of 5 equals. Now, when you are substituting in numbers into like a cube or a square or multiplication or division, please put parentheses there. It's going to make your life a lot easier. We're putting in 5 right here. That is my input. That's why I put it in green. And we're going to cube it. Okay, so let's go back and solve this. So now I have f of 5 equals, okay, what's 5 cubed? Well, what does 5 cubed mean? That means 5 times 5 times 5. It times itself 3 times. That gives you 125 minus 25. And that gives us 100. So f of 5 gives us 100. Now again, I kind of went crazy on that guy. Again, we want you to label that output. I'm going to use red again to highlight that's the output. So green is input. What comes out of that machine is 100. Now over here, I'm going to be typing something because I think it's confusing what this means. And I know it's brand new. So whatever I'm typing, I also want you to write, okay? And I'm gonna make that black. Okay, so I have f of 5 equals 100. That's that statement. But what does that mean? We're always gonna ask you, what does it mean? So underneath this, I'm gonna write out what it means. When x equals 5, y equals 100. And I also want you to type this. I want you to start understanding that inputs and outputs are coordinate points. That's just a coordinate point. So if we were to graph x cubed, which you guys know it's the crazy s, minus 25, if we were to graph that, that point 5, 100 would be on that graph, okay? All right. Stop the video here. Make sure your notes look like mine. And again, everything that I typed out, also put in those notes. So if you're like, I'm not quite sure what it should look like, let me show you. So let me, oh, no. Hang on, guys. I have to clear off my, pictures here, and then I will show you what it should look like. So that's what your notes should look like. Pause it here. Take a minute to absorb what f of 5 equals 100 means. You know coordinate points, it's just a point on the graph. Okay. All right. Box 3. So that lower left corner needs to be titled function notation. And now you need to put in this function. Well, here's the thing about Algebra 1, guys, is that again, we start with something you know. You know about evaluating expressions. Then we gave you problems with a function machine, so you can see a number actually going into the machine. But when you're in Algebra 1, we want you to get to a place where you just understand the pure algebra. So notice box 3 is exactly like the first two boxes. It's the same thing. You're just evaluating an expression, okay? But now we're using a pure algebraic notation, but it means the same thing. So again, let's try this. So I'm gonna, again, type something out because I want you guys to see what this is. And I'm going to use yellow, I think. All right. So we're given a function, f of x equals the absolute value of 4 minus x. Notice f of x is just a fancy y. But you're just given this thing called f of 9. So what does f of 9 even mean? Yes, what I type out, please write down. So what does f of 9 even mean? Well, it means, okay, this is what it's asking. When x equals 9, what does y equal? Y equals what? So that's that whole f of 9 translates to x equals 9, what does y equal? Notice it's a mathematician's way of making it easy to understand without having to write out a bunch of words. But f of 9 can look confusing because we're not used to it, but that's all it means. So let's do this problem. All right, I better get my pencil back. So I'm gonna look at, but I don't want yellow. Okay, we're gonna look at f of 9 equals the absolute value of 4 minus, and I'm going to leave a blank there because I have to input something in for x. Well, what am I inputting? Well, here we go. Again in green, that's my input. F of 9 means when x equals 9, that is my input. So again, green means input. All right, let's try to finish this problem. So I have F of 9 equals, okay, so what is 4 minus 9? I hope you're answering at home. It's okay to talk to the computer. Talk to me, even though it's virtual. Answer my questions when I ask them. Nobody's around listening to you, okay, except for maybe your dogs and your cats. It's all right to talk out loud. So 4 minus 9 gives us a negative 5. So we're not quite done though, because now what's the absolute value of a negative 5? Somebody said it out there. You are right. It's a positive. Remember, absolute value takes all negatives and makes them positive. So there is now my output. That's my red. So again, what does that f of 9 equal 5 mean? So again, I'm going to type. Please write what I'm going to type here. Okay, let me move that over. So here's what it means. When x equals 9, y equals 5. Okay, again, it's just a coordinate point, guys. That's all this is really saying is if I'm going to graph the absolute value of 4 minus x, I'm going to get the point 9, 5 on my graph. Okay, take a minute and write out what you see here. Make sure you solve this on your question. Pause your video, make sure it's all here. And here is what it should look like when you are finished. Okay, so that's my handwritten part. It's the exact same work, it's just my handwriting instead of the virtual pen. All right, guys, last one. Box 4. Box 4, of course, is the hardest. We start with what you know, we give you a function machine, and then we give you the pure algebraic piece. But in Algebra 1, we will always ask you, can you work backwards? And so this last problem is a working backwards problem. Go ahead and copy it, and let's talk about this one. So working backwards, when you are working backwards, you know how to do this. It's just now that you have been given the output and you're asked for the input. So what does this mean? F of x equals 10. Well, remember, f of x is a fancy way of saying y. So this really means y equals 10. That means, okay, let me write this out. Let me type it out. This is asking when y equals 10, what? Ooh, let's see if I can spell what. What does x equal? All right. That's the question that this is asking. Let me get my, no, I want to draw now. I am not working this very well. Now it'll go to yellow. So that f of x equals 10 is really that question. What is x when y equals 10? Okay, so it's the same type of question. We're just now going to work backwards. Okay, let's solve this one. So now I know f of x equals 10. So I put 10 equals 3x plus 7. Notice I did not put it in for x. This right here, guys, is the output. That is what I'm trying to get to. I want to know what I inputted to get to that. Okay, let's solve this. So I'm going to subtract 7 from each side. Working backwards requires you to go backwards to the equation. So now I have to go through this. So 10 minus 7 is 3, and I get equals 3x. Okay, what do I have to do next? How do you undo 3 times x? I know somebody out there said it. You divide by 3. Okay. and you end up with x equals 1. So now this is the input, and that's what I've been asked to find. Okay, that's my green. Notice on this working backwards, I started with red and ended up with green. I started with the output and came back to the input. Okay, so one last, what does it mean? All right, this means f of 1, but it's hard to see in yellow. F of 1 equals 10. That's what this whole thing means. So when x equals 1, y equals 10, and you get a coordinate point 110. If we were to graph this, 110 would be on our graph. Okay, let me just clarify. These notes are going to summarize the most important part of chapter 1. Can you take a number and put it into function? And can you understand function notation? We start with where you left off in your last math class, and we move you through function machines and then finally function notation, and then we ask you to work backwards. Again, we will probably do about 10 of these type of notes. It's very important, everything that you see here that I've typed, that needs to be in your notes, because remember, in a year from now is when you're going to look at these again, or maybe when you take your final in May, you're going to have to take a final that covers the entire year and you're studying. In May, you're going to look at these and say, oh, I remember function notation because I took such good notes. All of the Algebra 1 teachers, Mr. Evans, Mr. Reed, myself, and Mrs. O'Day, we are going to be looking at your notes to see that they are complete, they are accurate. If not, then we're going to have you redo them. Okay, that's how important this is. So please don't just slop your way through these. So if you want to see the final, like here's what it should finally look like. That's what that one looks like. Okay, you can pause the video and finish. But this is going to be the entire notes. Okay, notice I have my 4 boxes that represent the 4 types of questions that you are going to be asked on your very first short cycle. If you know how to do these 4 functions or these 4 problems, you are going to be fine. Now we're going to practice a lot in class, okay? But you need to bring these notes with you to your next in-class day. We're going to be checking them and giving you a grade for them. So thank you, Algebra 1. Take the time, pause the video here, make sure your notes look like this, bring them to class. Can't wait to see what you guys produce. We will see you guys in class.